Okay, so here we wish to find a potential for the conservative vector field with these components. And to explain the method that we're going to use, let's call this the first component P and the second component Q. The idea is that we wish to find a function phi such that phi sub x is equal to P and phi sub y is equal to Q. So the idea is simple. We begin by taking the guess that this function should be the integral with respect to P of dx. I'm sorry, the integral of P with respect to x. And that will end up being some function depending on x and y. We integrate by thinking of y as a constant, and we find some function g of y as the traditional constant. And g of y has to be chosen carefully so that whenever we take the derivative of this with respect to y, we find q. So by doing these two steps, we ensure, first of all, that the derivative of what we end up finding with respect to x is p, and also that the derivative with respect to y is q. Let's see how this is done here. So our first guess will be that we have to take the integral of the first component, meaning 2xy squared plus cosine x with respect to x. What does that mean? Y squared is treated as a constant, so this will be x squared, y squared plus sine x. And now instead of just putting plus c, we add an arbitrary function of y. And now it's this function of y that has to be chosen appropriately. So the idea is that if we take the partial derivative of this, we should end up finding e to the y plus 2x squared y, meaning q. Well, let's take the partial derivative of this with respect to y. So we have x squared times 2y. The derivative of sine x is 0 plus g prime of y. That should be equal to e to the y plus 2x squared y. 2x squared y and x squared times 2y is the same thing. These two things cancel each other, and we end up with a conclusion that g prime of y is equal to e to the y, which means that we can choose g of y to be simply e to the y. So as our answer, we give that a potential, not the potential, a potential is given by x squared y squared plus sine x plus e to the y. And indeed, if you take the derivative with respect to x, you find p. If you take the derivative with respect to y, you find q. And that's all.